Today's lesson is called Solving Systems of Equations Algebraically Day 3. When is the elimination method not the best solving strategy? Compare the following four systems of equations. Which system is not set up properly to use the elimination method? I'd like you to pause the video and try this question on your own, and then when you are ready to go over the answers, resume the video. Okay, so if I'm going to compare the following four systems of equations to see which one does not make sense to use elimination method, make sure you understand and notice some things about elimination method that will help. So the answer to the question should have been number 2. Here's why I know that, okay? Couple things you want to look for elimination method. If the equation is in standard form, which means the x and the y are on the same side together, or whatever variables they may be, that's a hint in the right direction that you should be using the elimination method. Another thing that people look for is the like variables line up. And then sometimes it's just helpful to notice what it's not. So if I look at number 2, I can see that they're telling me what A equals. So I'll be able to take what A equals and put it in my second equation. Whereas if I look at number 1, number 3, and number 4, they did not tell me what M or N equals in number 1, what A or B equals in number 3, or what X or Y equals in number 4. So number 2 is definitely the correct answer here. Definitely the only one that sticks out that does not make sense to use elimination method for. So we want to talk about our other options for solving algebraically today, which is the substitution method. So we will now solve this system using the substitution method. We're going to solve the one that we chose, number 2. So we had A equals negative 2b, and then we had 5a minus 3b equals 13. If we know that a equals negative 2b, I'm going to put parentheses around it, that means I can take this expression and put it in a's spot in the other equation. I'm going to substitute it in. So my new 5a minus 3b equals 13 is really now 5 times, instead of A equals negative 2b goes in its spot, minus 3b equals 13. And now I have one equation with one variable that I can solve for b. 5 times negative 2b would be negative 10b, minus 3b equals 13. I then have like terms, negative 10b and negative 3b would make negative 13b. And then to get b alone, I would need to divide both sides by negative 13. So I see that b equals negative 1. Now the rest of the process is no different than what we learned for elimination. I still need to go out and find the value of a. This is kind of obvious to me which equation you would want to pick. You can technically pick either one, but if you pick a equals negative 2b, you'll be able to plug in and just do some simple math rather than having to solve an equation. So we would have a equals negative 2b, but I already know that b is negative 1, and so a equals 2. And so now, technically it's not x and y, but it's a and b, and you're going to write them alphabetically. So you have an a value of 2, a b value of negative 1, and you use your squiggle brackets to have it in set notation. If you are going to check this, remember you have to check it in both equations, and it must check in both. On the side, I would like to write down just a little reminder to you of what we did. When we had a equals negative 2b, this means that the value of a is negative 2b. And so that means you replace a, our variable, with negative 2b. And I do think it helps to put the parentheses around that value and draw the arrow to the other spot just so you understand what you're doing. But of course, it's not mandatory. In our second example, we're going to solve the system of equations, And it says 7x plus 2y equals negative 4 and y equals x minus 5. Now again, if I'm trying to decide which method to use, substitution is the best for a couple of reasons. First reason is they're telling me what y is equal to. Y is equal to x minus 5. I can also tell because it doesn't look like elimination. The second equation is not in standard form. My like term variables are not lining up. So by process of elimination, substitution is the best method as well. So if y equals x minus 5, that means I'm going to take what y equals and I'm going to put it in the other equation in y's spot. So my equation that was 7x plus 2y equals negative 4 is now going to be 7x plus 2, and then in y's spot, I'm putting x minus 5. I'm substituting it in. Now I have an equation, one equation with one variable, and I can go ahead and solve for x. So first, distributive property. We have 7x plus 2 times x is 2x, 2 times negative 5 is negative 10. Then we look for like terms. We do have like terms, 7x and 2x makes 9x. Then we will look for variables on both sides. We don't have that, so we'll go into undoing the subtraction by adding 10 to both sides of the equation, getting 9x equals 6, and then dividing both sides by 9 to see that x is 2/3. Now remember, that's just my x value. I now need to go back and find my y. So I can pick either equation, although I think it's the easiest to pick the one that's already in y equals form, because then all I have to do is plug in 2/3 for x. And now I just have to do that simple subtraction with the help of my calculator, and I see that y equals negative 4 and 1/3. So now I know my answer is 2/3 and negative 4 and 1/3. And again, if we were asked to check, or you wanted to check on a quiz or a test, you would make sure that you check that solution in both 7x plus 2y equals negative 4 and y equals x minus 5. And that concludes our lesson on solving systems of equations algebraically, day 3.